The first thing we're going to review with radicals is simplifying. So, if I gave you an example, square root of 80, and I said simplify this, the first thing you would do was pull apart factors of 80 that contain a perfect square. So, 16 and 5. So technically, you're just rewriting the square root of 80 as the square root of 16 times the square root of 5. So the square root of 16 is 4. 5 can't be simplified, so this is your final answer. Alright, now, if I gave you another example where you had a value already out in front, again, you would ask yourself, okay, what multiplies to give me the square root of 50? What multiplies to give me 50 that contains a perfect square? And that would be the square root of 25 and the square root of 2. So, since the square root of 25 turns into 5, and there's a 4 out in front, you just multiply 5 times 4, you get 20, and then square root of 2. Alright, so if we were to add radical functions, say you had square root, there's two things we can do. We can say square root of 400 minus the square root of 36, and I could then ask you plus the square root of 144. So all of these are all perfect squares, so that's going to be 20 minus 6 plus 12, and we're going to get 26. The other option that you have is that, say I didn't give you perfect squared. So say I gave you the square root of 75 plus the square root of 27. What you have to do is you have to make both of these radicals have the same number under the radical. So they all have to be in terms of the same radical. For example, 75 can be broken into 25 times 3. 5 comes outside, so you have 5 root 3. So you're going to ask yourself, okay, I simplified that one all the way down. Can I make 27 have a radical of 3 in it? And you can. 9 times 3 gives you 27. So pulling out the 9 from the radical gives you 3, square root 3. So now that you have like radicals, you can add them. Kind of like terms. Like if this was 5x, you would only be able to add it if it was plus 3x, not plus 3y. Or not even just plus 3. It would have to be 5x and 3x to add it together. So we have 5 square root of 3, 3 square root of 3. So when we add them together, we're going to get 8 square root of 3. Alright, now we're going to multiply radicals. So your first example could be square root 2 times the square root of 14. All you need to do is multiply the insides. Unlike adding and subtracting radicals, you do not need the same number under the radical to be able to multiply them. So this gives you the square root of 28, and then you always check if you can simplify, and it does. We have 2 square root of 7 because 4 goes in the 28. Alright, so another example could look like 5 square root 8 times 2 square root 18. So this is a different type of example because you have the 5 and the 2 outside of the radical. So a couple of things you can do, and the first thing that I'm going to do is say, okay, well I can simplify the square root of 8 and turn it into 4 times 2. If I pull out that 2, I'm going to multiply it by 5. So technically I have 5 times 2 came out, square root of 2 is left over. And then over here, I could pull out a 9, which becomes a 3, so I'm just going to make that 6 square root 2. So I have technically 10 square root 2 times 6 square root 2, and my final answer is 60. Now, 60 is on the outside. 60 is on the outside because of the 10 and the 6. But just like we multiplied, not that one, just like we multiplied the 2 times the 14, we still have to multiply the 2 under the radical times the other 2. Okay? You don't do it where you just do 10 times 6 and then it's 60 root 2. That doesn't happen. You actually multiply the numbers under the radical. So you're going to actually have 60 root 4. Well, Can you simplify that? Yes, you can. Root 4 is 2, so you have 60 times 2, which is 120, and this is our final answer. All right, let's look at another example. All right, square root of 45 times the square root of 30. All right, let's simplify first. The factors of 49 that give me a perfect square are going to be 9 and 5. So I'm going to have 3 root 5 times the square root of 30, because that can't be simplified. So then I'm going to have 3 root 150, because I did 5 times 30. So then you ask yourself, okay, can I take something out? And you can. You could take a 5 out. You're going to take a 25 out, and so therefore 5 comes out and joins the 3, which makes it 15 root 6. And our last example of multiplication is the square root of 7 times the square root of 8. This looks like the first one, where we have the square root of 56. Can that be simplified? Yes, it can. I can pull out a 4, and I have 2 on the outside and 14 left on the inside. All right, we're going to look at 4 examples of dividing radicals as well. So, example number 1. If I give you the square root of 48 divided by 3, the first thing you can do is simplify inside. So 48 divided by 3 is 16. So now you have the square root of 16, and this simplifies to 4. All right, our second example. All right, if I give you the square root of 1/2, this is like saying the square root of 1, which is 1, over the square root of 2. Well, if you remember before, we cannot have square roots in our denominator. Not just square roots, but any radical can't be in our denominator, so we need to rationalize it. All right, so this is review. So you need to multiply it by the denominator, the square root of 2 times the square root of 2. And we do this because if you have square root of 2 times itself, that's like saying, okay, well, the square root of 2 squared, which just is 2. And that's the point. We just want 2. We don't want a radical in the denominator. And then you multiply the numerator, 1 times square root of 2, and you're left with root 2 over 2. All right, let's look at our third example. All right, so if I gave you 25 over 4, square root of 25 over 4, well, 25 over 4 can't be simplified as the fraction, but it can be simplified because they're both perfect squares. So you take the square root of 25 and the square root of 4, and your answer is 5 over 2. And our last example, example number 4, I could give you 49 over 2, square root of 49 over 2. Well, I can take the square root of the numerator, which is great, that's 7, but then I have square root of 2, and just like we did 2 problems ago, we have to rationalize it by multiplying the numerator and the denominator by the square root of 2. So, our final answer is going to end up being 7 square root 2 over 2. Nothing can simplify, the 2 has to stay under the radical, and that is it. So this was just a review of some radical stuff, some things that just might refresh your memory, some things you've seen before, and that's fantastic. So just go back, if you're unsure about anything, go back. You can always pause the video, rewind, write something down again, but be sure to take notes and be ready to work.